Welcome to the video on what are frames. In this video, you will learn about 2D and 3D frames, their classification, and some basic terminology in frame design. As mentioned earlier, a framed structure is a network of beams and columns, joined up to form the skeleton framework of the building. Frames can be designed as two-dimensional, or three-dimensional, as shown, depending on their purpose. Let's take a look at the different types of frames. Frames are broadly divided into two categories. Rigid frame structures can be defined as the structures in which beams and columns are interconnected by mostly rigid connections, which resist movements induced at the joints of members. Its members can take bending moment, shear, and axial loads. In braced frame system, diagonal members called bracings are usually provided between beams and columns to increase their resistance against the lateral or sideways forces due to applied load. Under rigid frames, you have pin-ended frames, which have pinned connections as supports, and fixed-ended frames, which have fixed connections as supports. There are two major types of braced frames. Gabled frame structures usually have the peak at their top. These frame systems are in use where there are possibilities of heavy rain and snow. Portal frames are generally low-rise structures, comprising columns and horizontal or pitched rafters, connected by moment-resisting connections. This form of continuous frame structure is stable in its plane, and provides a clear span that is unobstructed by bracing, which is useful for construction of industrial and commercial buildings. Let's take a look at some of the basic frame terminologies, which you need to be adept with, to perform frame analysis and design in the software. A story is the part of the frame on the same horizontal level, which includes the beams and columns, resting on one particular floor. The displayed frame has two stories, as shown. A bay is the spacing of the frame between two adjacent columns. The frame displayed here has three bays as shown. As mentioned earlier, bracings are the diagonal members placed in frames, which provide stability to the frame against vertical loads. The chords are the outer members in braced frames that hold the bracings. The frames are comprised of beams and columns. You have already learned about beams in the previous videos. So, let us now understand, what are columns? Columns are the vertical members in the frame, undertaking compression. They are responsible for transfer of loads, from the slabs and beams above them, to the footing below. Columns are axially loaded, with compression as a nature of loading. Due to loading, the column buckles along X direction, as displayed. If the loading in the column is eccentric, due to varied span of beams connected to the column, then there would be additional moment acting on the column, which is uniaxial bending moment, that occurs when the load is eccentric in either X or Y direction, with respect to the axial point. Or, biaxial bending moment, which is generated when the load is eccentric, in both X and Y directions, with respect to the axial point. To undertake the compressive loads, concrete columns, like beams, are embedded with a steel frame to provide reinforcement. The reinforcement provided along the length of the column is the longitudinal reinforcement, which resists the axial forces and the bending moments that the column is subjected to. As in the case of beams, reinforcement is also provided laterally, called lateral or helical ties. The main role of lateral ties in reinforced concrete columns is not to transfer the shear stress, as it is mainly in the beams, but rather to prevent the buckling of longitudinal bars and transfer of tensile stresses. You now have a better picture of the frame elements and their functioning. In the next video, you will learn to do frame analysis and design in the SAP 2000 software. Thanks for watching.